Now, let's talk about Windows executable format. Okay, now that you know how to build a program in Windows, let's talk about the format of these files. Let's see the guts of the executables in Windows. It's actually pretty complex, but I'm gonna give you a quick overview. Okay, so when you open a file, imagine that you have an editor, and it is called hexadecimal editor. You're gonna see it in the labs, don't worry. And when you open an executable or a DLL, those files that I'm gonna describe, you will have an structure inside, as you can see in the right side. So that structure, the first thing you're gonna be finding, meaning the first byte in the file, is gonna be a magic number. And then you have these multiple different values. When you see this word, means a size. Word is 2 bytes, double word is 4 bytes, Q word for 64 bits is 8 bytes. Okay. In this case, the magic number is 2 bytes, and then you're gonna be seeing in detail all the next ones in the next slides. Okay, let's go into the details. Magic number, you're gonna see is a 2 letters. You're gonna see in the next slide, and let's see what that means. The magic always starts with the magic number 4D5A hexadecimal, which is MZ, and actually this is the name of Mark Zbikowski. This guy was one of the original architects in Microsoft of the MS-DOS executable file format. This is one of the guys that created this guy, and lucky for him, he put his actual initials as the header. And as you can see here is the 4D and 5A right at the beginning of every executable in Windows today. Okay, now let's go into the next one, which is called this ALFA new. So that you don't get lost, remember this is the second guy here, right? So we have magic MZ, then multiple 2 bytes, 2 bytes, 2 bytes, blah 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 here, and then eventually you get to this LFA new at the bottom. If you sum up all of this, is 2, 4, 5, 6, 7, whatever, you get to this guy LFA new. Okay, so that you guys don't get lost. So where is that guy? So here is the MC, then you go all the way to LFA new, is right here. In this case is number 80. Very important, guys. You can see here 80 0 0 0 0. Why we have here 4 bytes? Again, let me go back. It says here double word, right? That means this value is 4 bytes. Okay, that's why we have here 4 bytes starting from this offset. Now, why this guy is 80 and is not 80 0 0 0 0? Okay, that's very, very important also. This is little endian format, meaning it is in reverse order, the way you will always find in a Windows system these addresses. Very, very important, guys. Okay, little endian. So now this 80 is the offset where you're gonna find the PE header, which is this guy here in red, in green color. Okay, so you see 80 here, you go to 0, 10, 20, 30, 40, 50, 60, 70, 80 here. Then you reach PE. 15 hexadecimal is P, 45 is E. Then you get into the starting of PE header. You see here, by the way, the DOS stop is just this string saying this program cannot be run in DOS mode. Is more for compatibility legacy issues. Nowadays is not used at all. But anyways, you guys get the idea, right? I mean, we can go deep, but you get the idea of how this is being parsed, right? You get offsets, and those offsets has some size. This is like a word, 2 bytes, and then you follow all the other offsets. You get to this offset, and you see what is this. Oh, this is an address of double word 4 bytes that points to the PE header. Okay, this is 80. Okay, here is the 80. This is the PE header, and then the PE header has some format, and then after that is section tables, and then sections numbers and those things. Right? That's the way you parse those guys. Obviously, there's many tools today that you can use to parse it. As I said, the DOS stop is just kept for legacy stuff. Now the PE header that I just mentioned, inside it has a structure that is called empty headers structure that has the signature. The PE is a double word 4 bytes, and then you have the image file header, then the optional header. Those are all the structures, very, very important, that we're going to be describing inside this PE header. Okay, let's go into the details. So the signature is the PE plus 2 bytes. Remember, it is 4 bytes of size. Okay, then we have the file header, which is a structure, which is 20 bytes. This is info about physical layout and properties of the file, like machine type, file type, etc. Then you have the optional header, which is the next 224 bytes, which is info about logical layout, address of the entry point. This is like where it's going to start executing the program, the size of the program, the image, and etc. Okay, continuing to the file header, let's go into the image header, which is, again, image header. We're going to go into this guy to describe it, and then into the second guy, optional header. Okay, so we go into the image file header, and then, as I said, it has physical layout. It has like information like machine name, number of sections, timestamp, pointer, and that's very important, guys, before going into that in the details. So let's see the machine. The machine is 2 bytes, and those can be 014C. That means a 32-bit machine. This value 8064 means a AMD 64-bit, and this 200 means a Intel 64-bit machine. And then, as an example, you can see here that, for example, here it is the 4C01, which is this guy. Remember, opposite for little endian, and this means this is a 32-bit machine. And then below you have a 6486, opposite little endian, and this guy is an AMD 64-bit machine. So when you run tools and the tool tells you, oh, you know what, this is a 32-bit executable, how do they know? Here is the reason how they know it's a 32-bit or 64-bit machine. Okay, now let's see a little bit more information about this. Number of sections is like how many sections we have here. 1, 2, 3, 4, 5. Timestamp, the day of the creation of the file. Pointed to the symbol table. You remember the symbol table, the number of the name of the functions and parameters. That's a pointer. The number of symbols. The optional header. That's another structure that we're going to see in a second. Characteristics tells you about the type of the file. We're going to see it in the next slide. Okay, characteristics tells you if it is an exe file or a DLL, right? For example, if you have a file that is like in this left side, this guy is an executable, has the check of it's executable, and is 32-bit. These two guys combined give us a 0102. That means 0102. Okay. Then when you look at the file, you see this. That means this guy has this combination, which is executable in a 32-bit machine. In the right side, you have a 32-bit machine, but it's a DLL. This guy is 2100. Guess what should be here if it would have been a DLL, this file? This would be here 0021, okay? And that would tell us this is a DLL. Again, keep in mind there is already tools that can parse this for us. Actually, this tool that you see here is called LordPE. Maybe it's not available yet anymore, but it's actually what they do is just to read all these offsets for us. Okay. Optional header. Okay, let me go back quickly, and we are in the optional header. We're talking about p header. We just described the file header. Now we're gonna go into the optional header, which is the second part of the whole structure that creates the p header. Okay, let's go to the optional header. Okay, optional header has a lot of information. As you can see, this is just right related to the program. So you have the address of the entry point. This is the address where the program is going to be executed, the entry point. Very, very important. Whenever you start analyzing malware, you need to understand where is the main function, where everything starts, and everything starts in the entry point. Image base, where is this file going to be loaded in memory? That's very important. Section alignment, you know, what are the offsets at virtual space where those different sections are going to be aligned. We're going to see that in a second. File alignment, this is the same alignment but on disk. So you basically have a file on disk, and it's basically resting on disk, and is different when you load it in memory. So when it is on disk, you have a file alignment so that you can see how it is being spread on disk. But when it goes into the memory, you have a section alignment, which is now in offsets of 1000. You will see in a second. And you have many other options that we're gonna dive some of them in a second. Size of the image, you know, the size of the file. And let's continue with interesting ones, DLL characteristics. This tell us the properties, like for example, if this executable has properties for protection. This is very important for exploitation. These are protections for the binary so that it can be protected for buffer overflows and dynamic loading and structure handling. Those are some exploits, some sort of attacks that this can help the programs to be more secure, and those are for DLL characteristics options. And as before, those are also activated, and those have in specific flags to be ready to be set, and then so that you know if those are activated or not. Then you have the data directory. This is very, very important, which is an array of directories. Let's see what is that. Data directory is very, very important. Data directory, it has multiple tables. You have export table. Export table basically is used for DLLs only. That means you will have a DLLs. For example, the DLLs, they have an export table so that they can show which are the functions that this DLL can be exposed to the executables, you know. So the export table tells everyone, these are my functions that me as a DLL you can use, right? That's for DLLs only. Import table, the import table is the DLLs that are used by the binary, you know. So in other words, import table is for executables, exe, export tables is for DLLs, and basically both tell us which are the functions that you are able to use in your program. Resources is like you have icons, encoded data, but there is where malware hides also information. Security, you can have certificates or fake certificates if you are a malicious guy. So you pretend to store certificate there, but it's actually malicious code. TLS is like a second entry point where your program can start. This actually starts before the main function. So attackers can put malicious code here so that when you think that you're going to start executing at the main function of your program, suddenly you see that you are already infected. That means it was already run. And sometimes it's because they put code in the TLS entry. So that's important for you to know. Okay. Let's see an example. For example, here we have the export table, as I told you. We have a DLL here, and since this is a DLL, you can see that we have an export table. At the export table, you can see that it says, okay, this procs DLL has an export table which has all these functions: get module handle, get module path, get module size. Meaning, if someone used this DLL, they have all these functions available. That's why the export table is used for DLLs, okay? But also, you can have other cases, like in this case, you have multiple DLLs, like you have here kernel DLL, or you have all of those functions. And then in this case, you have a DLL that has an import table. I lied before because I told you that import table is only for executables. I lie because it's also for DLLs. But in this case, see the difference. Very, very important. So the DLL has an import table. That means which are the functions that the DLL is going to be using. Okay? But these functions can come from other sources, can be some of the functions that the DLL is going to be using, but normally those are functions that are provided by other libraries. Okay, so in the difference between export and import is export are functions that the DLL makes available for everyone to use. So if you want to use this prox DLL, you can use all these functions. So if I am a program that I am going to be using prox DLL, with export table, I tell you as DLL which are the functions that you can use. Okay, export table. And then the import table says, okay, I am a DLL or executable, and then I have these functions that I am using internally. That's why it's import table. Functions internally that my program is using, okay, for whatever purpose I have. Okay, that's the difference between export and imports. Now, let's talk about the section table, okay? So the section holds the main content of the file, and the sections are, a program has multiple sections, and let's see what are those sections. Before that, you have a section which is a name of the section, the size of the section, the address in the memory, where it starts, and the characteristics. Okay, for example, here you can see that a file, like in this case, we have this file here. You can see that it has many sections. You can see here it has text section, data section, R data section, and every file can have different sections here. Okay, normally it's text, data, R data, and BSS normally, but you can add more sections as you want, and attackers can always use new sections to hide malicious software. That's why it's important to understand what the sections are and what are their permissions. Okay, like text, as I said, is the text section is used for executable code. All the code that is being executed by the file is in the text section. Okay, the data, R data, and BSS sections, those are more for static or global constants. Normally those are used for that. The RSRC section is for resources, icons, cursors, bitmaps, and as I said before, this section is normally also used to hide malicious code by attackers. The eData is the export directory section, mainly for DLLs, but it's pretty much it. And the import address table is for the eData section.